Hi friends, here we have this function x times x square minus 1 by absolute value of x square minus 1. Can it be made continuous at x equal to 1 or minus 1? This is the question. When can a function be made continuous? When there is a hole. So let's say for example we have a function like x square minus 4 by x minus 2. This is, let's say, some f of x, or let's call it some g of x. Right. Now clearly g of x is not defined at x equal to 2. When we say limit x tends to 2 g of x, what do? We cancel this x minus 2 in this, and then we'll we'll take this x plus 2 once we cancel this x minus 2, and we'll substitute this 2 here, and we'll say limit x tends to 2 g of x is actually 4. And if you say g of 2 is equal to 4, then we can actually fill that hole. At 2 there was a hole, let's say this point is 2, at this 2 there was a hole, and we'll say we'll fill this 4, we'll fill this point with 4 to make it complete or to make it continuous, right? Because this function is identical to x plus 2 at all points except at x equal to 2, right? And x plus 2 is a straight line like this, right? Except in x plus 2 there is a hole here, and that hole we fill with 4 to make it continuous. Now this given function x into x square minus 1 by absolute value of x square minus 1. See, x square minus 1 by absolute value of x square minus 1. This is either plus 1 or minus 1, right? Because it is essentially the magnitude is same. The bottom one is positive, the numerator can be positive or negative. It can be plus 1 or it can be minus 1, depending on what. X square minus 1 is greater than or equal to 0. Then this is positive, or x square minus 1 is less than 0. Then absolute value would be negative. So absolute value of y would be minus y if y is negative, right? Now here we have to take care that x square minus 1 is in the denominator, so it cannot be equal to 0 also, right? So it has to be strictly greater than 0 or strictly less than 0. What does that mean? X square minus 1 is greater than 0. When is this? When x belongs to 1 to infinity union minus 1 to minus infinity to minus 1. Minus 1. Right. In this range, x square minus is positive. So this function will change it to x, because this by this is actually equal to 1. On the other case, when x is between minus 1 to 1, right, x square minus 1 would be less than 0. In that case, the ratio would be minus 1, because the absolute value of x square minus 1 is minus of x square minus 1. So this function becomes minus x. What does that mean? What that means is between minus 1 and minus 1 and 1, the function is minus x, and between 1 to infinity and minus 1 to minus infinity, the function is actually equal to x. It looks something like this. This point is 1. From 1 to infinity it is x, and minus 1 to minus infinity it is again x, and between minus 1 and 1 it is actually minus x. The graph of it looks something like this. After 1 it is x, this line is x, this line is also x, but this line is minus x, right? Now clearly there is no way we can extend the continuity, because there is a big gap here. If there was a hole somewhere here, if there was a hole, then we could have filled that hole, right? Now there is a big gap, right? There is no way we can make this continuous, right? If there is a hole, we could have made it, but clearly there is no way of making this function continuous. So it cannot be extended to be continuous at 1 or minus 1. At all other points, it is actually continuous, right guys?